Hi, everyone. Today we're going to talk about histograms, how to make them, and how to work with them. The first note you want to make for yourself with histograms is that they are for quantitative data. So you wouldn't use this for categorical data. It's for when the variable takes on numbers that mean something. So it's going to look very similar to a bar graph. It, it's not quite the same. We'll go through why it's not the same, but it'll look similar to that. So what we want to do is show the frequency of a given data set. Now the frequency is just a count of how often does a piece of data appear in our data set. So we may have those in terms of counts. We may also choose to divide the frequency by the sample size. And when we do that, that'll be called, instead of how many times it'll happen, it'll be called a percent of what occurred. So instead of saying I got the number 7 5 times, I might say that's 20% of the data. Now, another name for that, just in case we come through it along the way, is called relative frequency. And when you take the counts and you turn them into a percent, that is what relative frequency is. We break up the data into intervals. So, for example, instead of having individual pieces of data, we might say all the data between 0 and 5, and then between 5 and 10, et cetera, et cetera, et cetera. The bars in the histogram should be joined together unless there's gaps in the data. So you're going to see bars like this. And if you see a gap where the bars aren't touching, that means there's no data here. So whereas in a bar graph, it doesn't matter if there are differences, if there are gaps between it. So for example, these are the people who like red and who like blue. This gap doesn't mean anything in a bar graph, but in a histogram it does. And that's really the main difference between a histogram and a bar graph. A bar graph's for categorical data, the gaps don't matter, whereas a histogram's for quantitative variable and the gaps do matter. So histogram is like sorting into bins. We take the data and you sort by putting them into bins. Again, all the zeros through 5 in one bin, all the 5 through 10s in another. So how do you create a histogram? You divide the range of data into classes of equal width. Now, what width? I could make them. Typically, we could have them 10 units wide or 5 units wide or even 1 unit wide, depending on what it is. This is actually more of an art than a science. For example, here's a dot plot. And if I make it look like a histogram with many, 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 many of those bins, you can see that it's hard to even look at this, yet alone talk about its shape, which we already talked about. It looks very similar to the dot plot. Now, this is many, many, many bins. Now, if we only had one bin of all the data, it would just be this big rectangle. And this doesn't show me anything about the shape. So finding the number of bins to use is kind of a science. Sorry, it's kind of an art. You want to be able to see the shape, but too many bars and the shape gets convoluted. Too few bars and you can't even see the shape at all. So we try to find a nice balance so we can see what's going on in the data and represent it. So there are many ways you could make a histogram. You should understand that right off the bat. Typically size 5 or 10 is pretty normal for the size of the bin, but it all depends on how the shape's going to look. Again, it's more of an art. So the horizontal axis is going to be the data itself, and the vertical axis is going to be the frequency. It could also be the percent. Each bar represents a class, and the base of the bar covers the class. The height is the count. There's no spaces between bars unless a class is empty. So notice we've created bins. So over here, they've already taken the data and created bins, and they've took anyone between 5 and 14 and put them in the first bin, between 15 and 24 in the second bin, et cetera, et cetera, et cetera. When I add up the frequency, when I add all these up, this is my n. It's how many people were in my data set here. And if I add it up here, it's actually going to add up to 100. So that's my sample size here. To create relative frequency, remember that's the percent. To create relative frequency, you just divide by n. So in this case, n is 100. I just take these frequencies and divide by 100. Now, because the sample size happens to be 100 here, this is going to be a very easy calculation for us. So it won't always be over 100. It'll be whatever the sample size is. But then I could also give the percents for each one of these categories. So 12 over 100 would be 12%. 30 over 100 is 30%. 20 over 100 is 20%. 1500 over 100 is 15%. 14 over 100 is 14%. 6 over 100 is 6%. And 3 over 100 is 3%. And so you can either make this y-axis here, it can either be frequency, the counts, or it could be that relative frequency, which are the percents that they occur. So there's a couple ways to make the bottoms of the histograms here. You can do 5 through 14, just like that. The other way you could do, I could start this bar at 5 and make the next one 15. Now it's known that 5 is going to be in this bar to the right. 15 is in this bar to the right. So I could go 20, and then 35, but 35 would be in here. 45, but 45 would be in here. 55, but 55 would be in here. And 65 in here. So you can choose to set up your histograms either way, but if it is set up this way, just remember that the number is always in the bar to the right. It's the bar to the right. And so one of the things we'll be able to do with looking at a histogram is talking about its shape. We can see here it's got this tail to the right here on it. We would call the shape of this distribution skewed to the right. The skew is the tail. Here's another histogram for you. This one's about how often you get different amounts of chunks of email, of pieces of junk mail in the mail. And they counted how many times people got a number between 0 and 4. So one of the downsides of a histogram is we don't know specifically whether how many ones or zeros are in here. We just know there's 25 between 0 and 4. That's one of the downsides of histograms. And remember, I can make this 0, 5, 10, 15, and 20. And it's known that the 0's in here, the 5's in the bar to the right, the 10's in the bar to the right, the 15's in the bar to the right, the 20 is in the bar to the right. Notice on this one, it's in terms of frequency. If I divided these by n, either here, here, and here, then I could do it in terms of relative frequency, which is just the percent. So let's go to number 2. Let me make sure you know how to do relative frequency. So the first thing I would do to find relative frequency, remember, is the percent that it happens. 20, 18, 6, 2, and 1. We want to add all these up. So that's 38, 44, 46. My n here is 47. So to get my relative frequencies, I would just divide all these frequencies by 47. And yeah, that'll be a nasty decimal. But I would just write those down, round them off. Usually to the nearest tenth is good. And that'll tell me what percent of the time I got each outcome. So what's going to happen now is the video is going to pause, and you want to make your own histogram here using the frequency list. So you want to set up your bins on the bottom, your frequency on the left, and then you want to make a histogram of the frequency. And we'll check back in after you do that. So your graph should have ended up looking something like this, your histogram. Remember, the other thing you could have done on the bottom here is you could have had from 0 until 2, and then to 4, 6, 8, and up to 10. So that's the other way you can do the bottom of the histogram. Either way is fine. So check to make sure you have your labels here, frequency on the left, and the bottom is what these numbers are about, which were hours per day. Notice I just took those out of the table, and then you also want to have a title pieces of junk mail on top. This next one, we're given a histogram. We're asked to find some information about our histogram here. So let's make sure we know how to do a histogram. One of the nice things to do with a histogram when you get one is to start out by writing down how many are in each category. So none there, there's 2 in there, there's 5 in here. In this category, there's 6. In this category, there's 8. In this category, there are 5. And in this category, there are 4. If we add those up, we'll get our n here. 2 plus 5 is 7, plus 6 is 13, plus 8 is 21, and add up the 5 and the 4 is 30. That's our n. And that is the answer to the first question here. There are 30 pieces of data in this histogram. Which age bracket had the highest frequency? That would be this 8 one here. That's between 50 and 59. Which age brackets had the same amount of winners? We're looking for the bars that are the same, which would be the 30 to 39 and 60 to 69. How many winners were there above and below 50? Well, below 50, there's 50. We add those up, 2 plus 5 plus 6, we get 13 below. And how many were 50 or above? 8 plus 5 plus 14 would have been 17 above. So that's how you use a histogram. If the bars are the same height, it's indicating there's the same amount of data there. If you add up the frequencies of the bars, it gives you your total frequency. So here's another histogram for us to look at. Let's describe the shape. When I'm describing shape, I like to draw on my histogram to see what it looks like. And notice it's got a tail on a tail to the right. So the tail's on the right. We're going to call this skewed right. So remember that the tail is the skew. You might think this is skewed left because most of the data is to the left, but the tail is the skew. The tail is the skew. So how many students were questioned overall? I just got to add up all these frequencies. So add up the 7, the 9, the 10, the 9, all the way across the way. Add all those up, and if I do, I get 59. Again, that's what n is for us. Which weekly earning had the most students? Again, find the highest bar, and we'll see between $20 and $30 is the highest bar here. Which weekly earnings had the same number of students? Well, there's a few of those here. Looks between 10 and 20 and 30 and 40 were the same. And then between 70 and 80 and 100 plus 100 to 110 were the same. And then it looks like 80 and 90 and 90 and 100 were the same as well. 10 to 20 and 30 to 40 matched up. 70 to 80 and 100 to 110 matched up. And then 80 to 90, 90 to 100 matched up. How many more students earned $30 to $40 than over $100? Well, how many were 30 to 40? 9 students. How many were over 100 here? This last bar here, that's 2. We subtract those, it's 7. All right, now let's make a frequency table. Let's see if we can go backwards from the histogram to the frequency table. So again, the first thing I'm going to start is what were the bins here? And they were going up by tens. So the bins themselves here were 0 to 10, then 10 to 20, and let's keep going, 20 to 30, 30 to 40. And remember, the 30 is actually included in the next category. These bottom numbers are included in the next category. So 40 to 50, and I'll just keep going. 50 to 60, 60 to 70, 70 to 80, 80 to 90, 90 to 100, and 100 to 110. And then I'm just going to write the frequencies of each one of these students. So I'm just adding up the frequencies for each one. Sorry, not adding them up, just writing them down. 7, 9, 10, 9, 8, 6, 4, 2, 1, 1. And this is how you go backwards from a histogram to a table. And again, I'm just copying down what each bar's frequency was. That's what you do. All right, so the video is going to end now. And what you want to do is try this last problem on your own. You're going to make a frequency table. I gave you the sides of the bins to make. Then you're going to make a histogram, and then you're going to answer some questions about the histogram.